Okay, so to most of the volume problem, we could solve it by sliding or this method, right? However, let us look at this situation right here. Then to this one right here, I would like to rotate about the y-axis. Okay, so in this case right here, we have a hard time to actually figure out how do we actually do this problem. The reason is we don't have like the x right and the L X left, right? To actually to do the subtractions. So we will not be able to do, that's mean to calculate kind of like the R values that we have here, okay, to this problem. So therefore, it seems that this method is not working in this case. Then what do we need to do is we have to introduce another method we call the shell method or cylindrical shell method right here. Okay, so let's see how is the shell method work then. So instead of work with this method right here. Okay, so first of all, what I need to do is I need to actually show the volume of a cylindrical shell can be referred as V equal to 2 pi R H delta R. So what is R? R is the distance from here to here, okay? And kind of like the middle between R sub 1 and R sub 2, okay? It's the middle of this distance right here. And then the delta R, of course, is the distance of this, which is the difference between R sub 2 minus R sub 1. And then H basically is the height here, okay? Okay, so then, first of all, we need to know that R is R sub 2 plus R sub 1 over 2, okay? And then delta R will be R sub 2 minus R sub 1, okay? And now, we know that the volume of this shape right here, basically it will be the V sub 2 minus V sub 1. V sub 2 is the biggest cylindrical solid, and then V sub 2 will be the smallest, okay, the smaller, okay. And then now, then you will see that basically V sub 2 will be pi R sub 2 square H minus V sub 1 will be pi R sub 1 square H. Okay. Then of course, we could actually try to factor the pi H. Then I will have R sub 2 square minus R sub 1 square. And then, of course, what we could do here is we could factor this. So I will have R sub 2 plus R sub 1 times R sub 2 minus R sub 1. Okay, so then now, what do we have here? Then we know that this one right here is my delta R. Okay, so this is my delta R right here. Okay. And then now what I would like to do here is I would like to have this one to rewrite this into 2 times R sub 2 plus R sub 1 over 2. Okay. Then now we could actually have 2 times pi H R sub 2 plus R sub 1 over 2 times delta R. And then now we will let R equal to R sub 2 plus R sub 1 over 2. So we are going to have 2 pi R H delta R, where R equal to R sub 2 minus plus R sub 1 over 2. And delta R is R sub 2 minus R sub 1. Okay. And now let's see, how do we actually use this right here to help us to find the volume now? Okay, so let us look at this picture right here. Right now, I have this function is y equal to f of x, okay? And then I would like to rotate it between, along the y-axis right here, okay, and then the solid, it will look like this, okay. And then right now, what do we want to do is we are going to separate this into a surface strip, right? Okay, and then this strip right here is between x of I minus 1 and x of I. And then you will see that if we rotate, about the y-axis, what happened here is actually we are going to have a okay, we have something look like this right here, right? If it is small enough, then you will see that these two height right here, they are almost the same. Okay, if we cut it small enough. Okay. Okay, so now then let's see. Now let's S be the solid obtained by rotating about the y-axis. The regions are bounded by y equal to f of x, where f of x is greater than or equal to 0, y equal to 0, x equal to a, okay, and x equal to b. Okay. So we would like to rotate it this way. Okay. And now we are going to divide the interval AB into n subinterval. So basically, in this case right here, we will have delta x is b minus a over n. Okay. And let x of I star is an element in between x of x minus 1, x of I. So in this case right here, we would like to select x I star here. Okay. And now, if the rectangle with base x of I minus 1, x of I, and the height is f of x of I star, is rotate about the y-axis. Okay. Then the result is a cylindrical shell with the average radius is x of I. The height is f of x of I star, and the thickness is delta x. Okay. Then in this case right here, based on what we have, we could actually have v sub I is 2 pi x sub I star. Now remember, x sub I star is kind of like the r, right? It is right here. And then f of x of I star, f of x of I star basically is the height. Okay, so this is this is the h, this is the r right here. And delta x, basically delta x is kind of like the delta r that we have here to the previous example here. And then now, what do? We are going to sum I is from 1 to n of v sub I, which is this one, okay? And then now what do? We could take the limit as n go to infinity, which is delta x go to 0. Then we could rewrite it into the integral in this way. So the volume is the same as we integrate between a and b of 2 pi x f of x dx. Now remember, x is a distance from here, okay, which is the radius, okay, and then f of x will be the height then. So then this is actually the volume of rotations, the shell method then. The solid obtained by rotating the regions under the y equal to f of x over the interval AB about the y-axis, okay, has volume 2 pi integrate from a to b x times f of x dx, where x is the radius and f of x is the height of the shell. Okay, so keep that in mind. Okay, then now, when we rotate the regions between the graph of two functions f of x and g of x, okay, f of x is the biggest function and g of x is the smallest functions. Certify that f of x is greater than or equal to g of x. The vertical segment at rotation x generate a cylindrical shell again, of a radius x of height f of x minus g of x. Okay, so therefore in this case, if we have two functions, what we need, again, we just need to figure out what is this height, and the height will be f of x minus g of x. So then we have another formula. Okay, again, the idea is still is 2 pi integrate between a and b of the radius times the height of the shell dx. Okay, so then now let us look at our first example. So now remember, to this one, always try to sketch the function to see what we are going to have. Okay. Okay, so in this case, we are going to have, again, we have 1 over x. Okay, so the function is like this. And then we would like to work with the integers from 1 to 3 here. Okay. And then now, what do we want to do is we would like to rotate it about the y-axis. So we rotate this way. Then, in this case right here, what we are going to do is, you will see that here, what happened is, okay, so we will have something look like this then. Okay, so this is what we're going to do. Okay, then now, let's see how do we actually do this. You will see that here, what happened is, we could actually cut this, okay, to make a shell. Okay, okay. Then you will see that what happened here is this is my r, this is the radius, and this is the height that we have. Okay, so then the volume, it will be 2 pi, we integrate between 1 and 3. Okay, so again, we are working with the radius times the height. Okay, and then in this case, we work with dx, right? Okay, so then, now what is the radius? Okay, so therefore, in this case, the radius basically is just x. This is actually is the x value right here, between x equal to 1 to 3, right? And then the height, of course, is 1 over x then, which is the function that we have. Okay, so then now, we will have 2 pi 1 over 3 and dx. And of course, this will be 2 pi x integrated between 1 to 3. So then, so my answer is 4 pi then. Yeah, that's it. Huh? You will see that this is using the shell method, sometimes it make the problem easier to solve then. Okay, so now, again, we would like to use the shell method to actually to work with the following volumes, okay? So to this one right here, we have two functions, y equal to 8 minus x to the power 3, and another one is y equal to 8 minus 4x. First of all, to this function right here, we need to work with a negative x to the power 3, and then we have the y-intercept is 8. So then, in this case right here, we have the y-intercept is 8, and then we right, something like this. And then of course, when y equal to 0, then x is equal to 2. So I know that this is 2 right here. And now we are going to work with 8 minus 4x. I have the y-intercept is 8, and then the x-intercept is when y equal to 0 is actually 2. That's nice. Okay. So then this one right here is y equal to 8 minus 4x. And this one right here is y equal to 8 minus x to the power 3. Okay, so now let us simplify this graph right here. Okay, and again, this function right here is y equal to 8 minus x to the power 3. This one right here is y equal to 8 minus 4x. Okay. And then now, what do we want to do is, we would like to rotate about the y-axis here. Okay. So therefore, you will see that again, the shell that we are going to make is like this. So again, we work with delta x right here. And then you will see that this is the function greater than this one. Okay. So and now we are going to set it up now. So we would like to integrate between 0 and 2. Okay. And then it will be 2 pi, again, what is the radius? And then what is the height? Dx. Okay. Okay. You will see that the radius basically is this beading right here. Okay. So therefore, this is actually is the radius, which is x right here. So I have x. And then the height, which is the difference between the two functions, h minus x to the power 3 minus h minus 4x. Dx then. Okay. Okay, so then now let us simplify the problem. Okay. So then you will see that we are going to have integrate between 0 and 2 pi, and then now I will have negative x to the power 4 plus 4x squared dx. Then now I will have 2 pi, then negative x to the power 5 over 5 plus 4x to the 3 over 3, integrate between 0 and 2. Then negative 32 over 5 plus 32 over 3. So I will have 2 pi negative 96 plus 160 over 15. Okay, so then the volume will be 128 pi over 15. Okay, so then now let us look at the next example now. Okay, so first I would like to sketch the solid obtained by rotating the regions underneath the graph of f of x over the interval about the given axis, and calculate the volume using the shell method. Okay, so again, we are using the shell method. Okay, so first of all, I'm going to graph the okay, so I have the function is x to the power 3. Okay, And then, oh, maybe just do this one. Okay. And then between 0 and 1. Okay. And then now I would like to rotate about, let me make this smaller. Okay. And then I would like to rotate about x equal to -2. Okay. Then you will see that what happened here is, okay, then we would like to have this one. And then now you will see that to this is all. Okay. And then the height is this. Okay. Then now I would like to find the volume in, I will have 2 pi integrate between 0 and 1 of the radius multiplied to the height and dx. Okay. And now we know that the height basically is x to the power 3. This is what we know. But how about the radius? Okay, so now you will see that the radius here is this, basically this is actually is from here to here basically just the x value, right? And then from here to here is 2 units. So therefore in this case right here it must be x plus 2 then. Okay. Okay, then now so we'll have x to the power 4 plus 2x to the power 3. Okay, and you see that this time 2, this time 5. Then I will have 2 times 7 is 14 pi over 10, which is equal to 7 pi over 5 now. Okay. Yes. Okay. And now, how about this one? Okay. So we have 1 over x to the power 4. Basically, the graph that we have is something like this, right? Okay. But we only need to work with between -1 and -3. And that means this is the one that we need to work with. And then we rotate about, well, right here. Okay, so again, let me simplify this graph a little bit. So I would have from 1, 2, 3, -1, -3 to -1, this one. And then I'm going to rotate it forward here. Okay, so then in this case right here, what we are going to have this is, we are going to have this one is, okay, so again, then you will see that this is actually is my R values. Okay, then to this R value right here. Okay, so again, you will see that from here to here is the X, and then from here to here is actually 4. So basically, the value that we have, it will be what? It will be 4 minus X now. Okay. The reason this is we need to minus because again, this is a negative sign right here, right? So if I want to find values, that means I need to have 4 plus this distance right here. Okay. So therefore we should subtract. Okay. So then now the volume that we have, it will be 2 pi integrate between -3 and -1 of the radius times the height times the x. Okay, so again, this is the x. So it will be 2 pi -3 to -1 of 4 minus x. So again, when x is -1, then the distance from here to here is 5. When x is -3, from here to here, it will be 7. So that's why we need to have 4 minus. And the height, of course, the height will be x to the power of -4. Okay, then okay, so we could finish the problem now. So I will have 4 x to the -3 over -3 minus x to the -2 over -2 integrate between -3 and -1. Okay. Okay, then maybe let us simplify this. So I have -4 over 3 x to the power 3, and then plus 1 over 2 x squared integrate between -3 and -1. Okay, so then now I will have 4 over 3 plus 1/2 minus 4 over 81 plus 1 over 3, 9, 18. And then now my answer will be 280 pi over 81. Okay. Okay, then now let us try to work on the last two problems here. Okay, number 5 and number 6. Okay, to finish this section now. So again, I would like to use the shell method, okay, to find the volume obtained by rotating the region A. So we are going to work with the region A, okay, about the x-axis. Okay, so then in this case, we rotate about the x-axis. So basically, in this case right here, what do you see? You will see that we are going to have okay, so then if I want to draw, okay, okay, so we have something like this, create a shell method. So therefore, in this case right here, to the shell method, then we know that this is actually is my R, okay, and then this is actually is my H, my height, okay? And then now, of course, we are going to work with the delta Y now, okay. And now I will have V is 2 pi integrate between 2 to 6 of the radius multiplied to height dy now, okay. Okay, so then now let's think about this. You will see that the height basically is, we need to work with this one, so we need to solve for x. So x is equal to y minus 2, and then we take the square root, right? Okay. And then now, basically, what is the r basically is the y. So I will have 2 pi integrate between 2 and 6 of y times square root of y minus 2 dy. Okay. Okay, so then now, what we could do here is we could actually work with the substitution then, right, to solve the integrations. So we would like to let u equal to y minus 2, and then du is equal to dy. And of course, I will have u plus 2 is equal to y as well. Then now, when y equal to 2, then u is equal to, when y is 2, u is 0. When y is equal to 6, then u is equal to 4. So now, what we are going to do here is we would like to change everything to u now. So u equal to 0 to u equal to 4. And then I will have u plus 2 square root of u. If we get u to the 1/2 then dy. And now I will have 2 pi integrate between 0 and 4 of u to the 3/2 plus u times u to the 1/2. Okay. Okay. And now I have 2 pi, and then this one will be 2 over 5 u to the 5 over 2 plus 2 times 2 over 3 u to the 3 over 2 integrate between 0 and 4. Okay. Okay, so then now, step by step, huh? So we'll have 2 over 5, and then this one is 4, 5 over 2, plus 4 over 3, 4 times 3/2. Okay. And of course, to this one, this is 2 square right here. So I will have 2 pi, then this one is 2 to the 5th times 2 is 64 over 5 plus 832 over 3. And then now this is times 3, this is times 5. (192 plus 160 over 15). Okay. Okay, so then this is actually is my answer here. Okay, so let us get to the last problem. This problem right here is asks us to use the most convenient method, this or shell, okay, to find the volume obtained by rotating the region B. Okay, so which is this one right here. Okay, about the y equal to 8. Okay, so then let us try to graph this one first, okay, to see what we could do, okay, so this is 8. We are going to rotate it right here, then so the region B is here. Okay, so now you will see that if we're using this method, then it seems that it's easier for us to set it up. Okay, so we could create this like this one. Okay, it seems that this method is easier. So let us review this method first. Okay, so the volume, basically we integrate pi, integrate between A and B of the radius. Okay, outer square minus inner square, and then we work with either the y or the x, right? But of course, to this problem right here, we are going to work with the x then. Okay. Okay, so let's set this up. So I will have v is equal to pi. X is in between 3 and 2. My outer, okay, so you will see that my outer basically is from here to here. Okay, so my outer is 8 squared minus my inner is actually from here to here. Okay, so this is my inner. So basically what we have here is we are going to have 8 minus y then to the square, and then we are going to work with the x. Okay, so then now you will see that in this case we would like to work with x, so I need to convert y depend on x, and then we know that y equal to x squared plus 2. So then in this case, then we could have pi 0 to 2 of 64 minus 8. Maybe just copy it down first, minus x squared plus 2 to the square dx then. Okay. Then of course we are going to have this one. So I have 64 minus 6 minus x squared to the square. Okay. Okay, so then this is actually is what we have. Oh, it seems that it is easier to do. So then I have pi, then I have square root of 2, then this one will be 58 plus x squared. Oh, wow, my bad. So I have 64 minus 36 minus 12x squared, and then plus x to the power 4 and dx. Okay. And in this case, we will have 3. So I will have 28 plus 12x squared minus x to the power 4 dx. Okay, then so here's pi. So 28x plus 12x to the power 3 over 3 minus x to the power 5 over 5. Integrate between 0 and 2. Okay. And then now the answer that we have here is 408 pi over 5. So this is what we have. Okay, then this is actually using this method. Okay, and then now if we want to work with the shell, okay, the shell method basically is v is 2 pi integrate between a and b of the radius multiplied to the height. Okay, and then dx or dy, right? It's depend. Okay, so then this is actually is this method. here. Of course, to this one right here, if we want to work with this method, then what we need to do is we have to work with the delta y now. Okay, we work with this. Okay, so but one thing about this is now, if this is the case, then now what happened here is what is my radius? So you will see that the radius that we have here, basically this is my radius. And then of course, this is actually my height. Okay, now, one thing about this is the radius is okay, because we just work with the y value here. But the height is, in this case right here, this is 2. But after this point, okay, what happened to the height? The height is actually changed. Okay, so therefore, in this case, meaning we could not use the regular, that's mean one function to actually work it out the whole problem then. Probably we need to separate this into two parts of the problem. One part is actually let me draw this out. So, so in this case, what we need to do here is probably we need to separate this into two parts. First part is the radius is, okay, so meaning what is actually is from 0 to 2, then in this case right here, the height is 2, okay. And then the second part is actually is from 2 to 6 here. Then what happened? The height is actually is no longer 2, right? It will be 2 minus this x value right here. Okay, so then this is actually is we are going to separate this into two interval then. Okay, so then maybe let us talk about this. It will be v1 and v2. Okay, then what is v1? Then v1 is actually as we integrate it between 0 and 2. 2 pi 0 and 2. And then now we need to work with the radius now. So you will see that in this case right here, what is the radius? The radius is actually is, okay, the outer part is, that means is the height that we have is actually is 8. But now we need to subtract because it's changing, right? This is the y value. So therefore the radius in this case, it will be 8 minus y then, okay? And of course the height is just 2 y. Okay, so then this is actually is what we have, okay? And then now, we need to work with v sub 2. Okay, so again, to v sub 2, we are going to integrate between 2 and 6. Okay, so in this case, again, you will see that what happened to the height, the radius, it will be again is still 8 minus y. Okay. Okay, so then in this case right here, now again, you see that when y is equal to 2, then the radius is 6. Then we know that from here to here is 6. When y is equal to 3, then the radius, it will be 5, right? And so on and so forth, yes, okay. However, the height, in this case right here, it will be what? It will be 2 minus x then. Okay, we know that. And then now, of course, we know that in this case, x basically is equal to y minus 2, take the square root. So then now we are going to, so I will have 2 pi 2 to 6, 8 minus y, and then 2 minus square root of y minus 2 dy. Okay. Okay, so then in this case, the total volume, it will be 2 pi integrate between 0 and 2, 8 minus y times 2 dy plus 2 pi integrate between 2 and 6, 8 minus y, 2 minus square root of y minus 2 dy. Okay, wow. It's still workable, but it seems that this method is easier in this case right here. Okay. Okay, so anyway, then I think that to number 6, I would like to use this method to finish it. But of course, this is still workable. Okay, so we could find the volume using the shell method as well. Okay. Okay, so anyway, that is it for the section 6.3, which is working with the volume by using the shell method. Okay, so therefore again, between 6.2 and 6.3, we learning 3 techniques to find the volume. One is by sliding, another one will be by rotating, and then the last one is by shell. Okay, so then again, try to work on the problems. Okay, on warm-up. If you have any questions, again, send an email or talk to me. Okay, thank you very much.